just finished example 1, which was one giant example involving a table. So now we're going to talk about some examples that don't have a table. So we'll have to rely on formulas. Let me remind you what the formulas are. So the first one is the addition rule, which was a formula for finding ORs. And it says the probability of A or B is equal to probability of A plus probability of B minus the probability of A and B. This is a formula from the previous lecture. And then today, the new formula we talked about was the multiplication rule, and it's a formula for finding ands. And it says probability of A and B is the probability of A times the probability of not just regular B, but probability of B given A. Remember, for the conditional probability, the ones that have the given, the order does matter. So make sure it's A and then B given A. And then there's a third one, which is going to be useful for us. And you get that third one by swapping the A's and B's. So probability of B and A is equal to the probability of B times the probability of A given B. Right, so all I did was I started with equation 2 here and just swapped the A's and B's, right, and I got 3. So this is going to be useful because for ORs and ANDs, the order doesn't matter, right? So A or B is the same thing as B or A. A and B is the same thing as B and A. So the left side here is the same, okay? The right side is different, right? The right side of the first one involves a B given A. The right side of the third one involves an A given B, and these are different. So it's going to be useful because sometimes you'll have A given B, and sometimes you'll have B given A given in the problem. So that's going to determine which of these formulas you use. And then the rule of complements. So this is just a relationship between an event and its complement. And it says the probability of the complement is 1 minus the probability of the original. And the probability of the original is 1 minus the probability of the complement. Example 2. Suppose that the probability of G is 0.45, probability of H is 0.15, probability of G given H is 0.70. Find the following quantities. I don't have a table, so I have to rely on those formulas on the previous page. So what I'm going to do here is, these formulas are written with A's and B's. This equation, or this problem, is asking about G and H's. So I'm going to rewrite the formulas using G and H. So the first one is the addition rule. So I'm just going to replace A with G and B with H. So this is going to say probability of G or H equals probability of G plus probability of H minus the probability of G and H. The second equation is the multiplication rule, which is the one for ANDs. So it's a probability of G times probability of, make sure you have the correct order here. Is it G given H or is it H given G? It's H given G. So one way that I remember is, I know that it alternates, right? So G, H, G. And then the third one, you get by starting with 2 and then just swapping the letters. So this will say probability of H and G is equal to the probability of H times the probability of, once again, it should alternate. So it's H and then G given H. All right, so now we're ready to answer these questions. Part A, find the probability of G and H. So which equation should I use? So look for the equation that has a G and H in it. So equation 1, I see it right here. Equation 2, I see it right here. Equation 3, so this is in the wrong order, H and G, but remember I said for ANDs the order doesn't matter. So this is actually the same thing as G and H. So I see it in equation 3 also. Okay, so it's in all three equations, which one do you use? Can you use equation 1? I'm looking for G and H, which is right here. So for this equation to be useful, you need to know everything else. Okay, so do I know probability of G? Yes. Do I know probability of H? Yes. Do I know G or H? No, right? So I don't know G or H, which means equation 1 is not going to be useful to me. Okay, what about equation 2? G and H is right here. So for this one to be useful, I need to know everything else. So probability of G. Do I know probability of G? Yes. Do I know H given G? I know G given H. But remember, for the givens, the order matters. So these two are different. So I don't know H given G, which means I can't use equation 2. So the only one left is equation 3, right? So this is what I'm looking for. I know probability of H, and I know G and H, or G given H. So equation 3 should be useful to me. So let me write it out. Let me recopy equation 3. So it says H and G is equal to probability of H times the probability of G given H. And then now we just fill in stuff. H and G is what I'm looking for. So let's just call that X. Probability of H is 0.15, so this entire thing is 0.15. Probability of G given H is 0.70. And then I'm going to go through and fill in the symbols. So there's an equal sign right here. There's a multiplication sign right here. And then your job is to get the X by itself. The X is already by itself, so all you need to do is just multiply on the right side. 0.15 times 0.70, and it's 0.105. Okay, so what we just found was probability of G and H is 0.105. Part B, probability of G or H. So which equation is going to be useful? There's only one that has an or in it. It's equation 1. Right? So there you have no choice but to use equation 1. So let me recopy equation 1. And then we'll go through and fill in what we know. So G or H, that's what we're looking for. So let me just call that X. Probability of G is 0.45. Probability of H is 0.15. Probability of G and H, do I know that? I do, right? We did that in part A, right? So probability of G and H is 0.105. And then go through and fill in the symbols. So there's an equal sign right here. Be careful. There's a plus sign in the middle here. And then between these two, there's a minus sign. And then your job is to get the X by itself. The X is already by itself. So all you need to do is simplify the right side. So right side is going to be 0.45 plus 0.15 minus 0.105. And you get 0.495. All right, so we just found G or H. So probability of G or H is 0.495. Part C, probability of H given G. Okay, which equation has H given G? Okay, remember for the givens, the order does matter, so you need to see exactly in that order H given G. Which equation has a H given G? I see it right here. And that's the only place. So you have no choice but to use equation 2. Okay, so let me recopy. And then go through and fill in what you know. Left side, G and H. Right, so if you're paying attention, we actually already know that. We did that in part A. Right? G and H is 0.105. So I know this entire thing is 0.105. G was in the original problem. It's 0.45. H given G, that's what we're looking for. So let me call that X. And then we'll go through and fill in the symbols. So there's an equal sign here. There's a multiplication between those two, the 0.45 and X. And then your job is to get the X by itself. Okay, so here the X is not by itself right now, right? There's this 0.45 being multiplied. So to get rid of the 0.45, you're going to do the opposite of multiplication. So divide both sides by 0.45. Okay, left side, 0.105 divided by 0.45. Round this to 3 decimal places is 0.233. And then on the right side, 0.45 divided by 0.45, those cancel out, and you just have an X, and you're done. So what we just found was probability of H given G is 0.233. Part D. Are G and H independent? Okay, so let's go back and look at our notes. Independent. The question is, which equation should you check? You really have two choices: this one or this one. So which one? Independent, you should be checking this one. So probability of A equals, and make sure you have the correct order, so it's A equals A given B. And then because this question involves G's and H's, let me replace the A's with G's and the B's with H's. Okay, so what we're really checking is probability of G and then probability of G given H. And then you're just going to find the left side and find the right side. So left side, probability of G, we know is 0.45. G given H, that's not it, that's the wrong order. G given H, 0.70. Okay. If they're equal to each other, they're independent. If they're not equal, they're not independent. Obviously, these are not equal. So our conclusion here is that they are not independent. Part E, let G and H are G and H mutually exclusive. Right, mutually exclusive. You're checking the and, right? P of A and B is equal to 0. And then because we're talking about G and H's here, let me rewrite probability of G and H is 0. And then check left side, check right side. Right side's easy, it's just 0. Left side, probability of G and H. We probably did that already somewhere. Where do I have G and H? Right there. So G and H is 0.105. Okay, question is, Are they equal to each other or not? If they are, then it's mutually exclusive. If they're not equal to each other, then it's not mutually exclusive. So obviously, this would be not mutually exclusive. Example 3. Let C and D be events such that P of C is 0.8, probability of D is 0.6, and probability of C or D is 0.92. We don't have a table, so I need to rely on those 3 formulas. Let me rewrite them here. And I'm going to rewrite them using C's and D's. So instead of the A's and B's in the original, I'm going to rewrite them with C's and D's. The first one is the addition rule, which is the one for OR. So C or D is equal to probability of C plus probability of D minus the probability of C and D. The second one is the multiplication rule. This is the one for ANDs. So C and D equals probability of C times, and then the correct order here, it alternates. So it's C and then D given C. And then the third one, you get by just swapping the order of equation 2. So that's going to say probability of D and C equals probability of D times the probability of, it alternates here, so it's D and then C given D. Okay, we're ready for part A. Part A says, are C and D mutually exclusive? Right, so I see mutually exclusive. That means I should be checking some equation. Which equation should I be checking? The AND. Okay, so I'm going to write this using C's and D's. So I'm looking for probability of C and D is equal to 0. All right, so we're going to check C and D equal to 0. Okay, I'm going to find the left side, find the right side, and then see if they're equal or not. Right side's easy, it's 0. Left side, I don't know right now, so I actually have to find it. And we're going to find it using one of these equations up here. So which one has a C and D? It's there, it's also there, and then this is the same thing because the order doesn't matter for ANDs. So I see them in all 3 equations, so now I have to think, which one can I use? So I'm looking for C and D. In order to use the equation, you have to know everything else in the equation, right? So let's see if one works. I'm looking for C and D, so I need to know these 3 things. Do I know probability of D? Yes. Do I know probability of C? Yes. Do I know probability of C or D? Also yes, right? So I actually have everything I need for equation 1. So that means equation 1 is the one you want. So I'm going to rewrite equation 1. Let me write it. Yeah, I'll write it here. And then go through and fill in what you know. Okay, so C or D, so this entire thing, I do know. I do know it's 0.92. So that entire thing is 0.92. Probability of C, I do know the entire thing is 0.8. Probability of D, I know it's 0.6. And then probability of C and D, that's actually what I'm looking for. So let me label that with an X. And then I'm going to go through and fill in the symbols. There's an equals here. Between the 0.8, 0.6, there's a plus. And then between the 0.6 and the X, there's a minus. And then your job is to get the X by itself. Okay, so let me first simplify both sides. Left side, there's nothing to do. Right side, I can add those. So 0.8 plus 0.6 is 1.4. And then I still have this minus x. And then I want to get the x by itself. So to get rid of this 1.4, right, currently it's basically being added to this minus x. So I need to subtract both sides. Left side 0.92 minus 1.4 is negative 0.48. On the right side, 1.4 minus 1.4 is going to cancel out, and then I have a minus x. I'm looking for regular x, so if I know negative x is negative 0.48, I know regular x should be positive 0.48. Okay, so what we just found was x, which is probability of C and D. So I know that probability of C and D is 0.48. And the whole point of finding this was to actually check that left side, right? So this left side I now know is 0.48. And the question is, are they equal? No, right? So they're not equal. So our conclusion is that they are not mutually exclusive. Part B. So I'll do part B over here. Are C and D independent? Okay, so independent. I should be checking this equation. So probability of A equals probability of A given B. Right, so let me rewrite that. And then let me also rewrite it with our letters for this question. So we're using C's and D's. So it's probability of C equals probability of C given D. Okay. Check left side, check right side, and check if they're equal. Left side, probability of C, I know it's 0.8. Okay, right side, C given D, I don't think I have yet anywhere. Okay, so I actually have to find the right side. Okay, so I have to find probability of C given D using one of these equations. All right, so which one is going to be useful to me? All right, so for the givens, the order does matter, so it needs to look exactly like that, C given D in that order. Which equation? I see it right here. All right, so I'm going to use equation 3. So let me rewrite equation 3. So equation 3 is probability of D and C is equal to probability of D times the probability of C given D. And then go through and fill in what you know. D and C. Do I know D and C? Yes, right. D and C, remember for and, the order doesn't matter. So D and C is the same thing as C and D. And C and D, we actually found right here. It's 0.48. Okay, so that's 0.48. Probability of D, we know is 0.6. C given D is what I'm looking for to find this right side. So that's X. Go through, fill in the symbols. There's an equal sign right here. There's a multiplication right there. And then your job is to get the X by itself. Right now, there's a multiplication here. So I need to divide both sides by 0.6 to get rid of it. Left side, 0.48 divided by 0.6 is 0.8. Right side, 0.6 divided by 0.6 cancels out, and I have just an x. So X is by itself, and so that 0.8 was just probability of C given D is 0.8. So now I know that the right side is 0.8. And what's our conclusion? They are equal. Okay, so if they are equal, then our conclusion is that they are independent. Example 4. At a certain college, 80% of all students take statistics and 36% of all students take economics. Given that a student takes statistics, 30% of these students take economics. Part A, let S be the event that a student takes statistics, let E be the event that a student takes economics. Summarize in symbols the probabilities described above. So what I'm looking for is things that look like this, or this, or this. Okay? So the first probability here is 80%. So as a decimal, that's a 0.80. Okay, and then 80% of all students take statistics. So that's the probability of getting someone who takes statistics. So probability of S. The second percentage here is 36%. As a decimal, that's 0.36. And this represents the percent of students who take economics. So that's going to be probability of E for economics. The last percentage here is 30%, which is 0.30. And this stands for, given that a student takes statistics, 30% of these students take economics. So keyword here is the word given. So this is going to be a conditional probability. So in symbols, it's going to be something given something else, right? So the question is it S given E, or is it E given S? So the way the sentence is written here is that it says, given that a student takes statistics. So that's the given part, right? So given statistics, so given S. And where does the given part go? The first part or the second part? The given is the second part in the symbol. So that means that S goes in the second part, which means E goes in the first part. So this is E given S is 0.30. Okay, and then from here, we're going to need those three formulas. So I'm going to write out those three formulas. I'm going to write them using S's and E's. Okay, so the first one is the addition rule, which is S or E is equal to P of S plus P of E minus P of S and E. The second one is the multiplication rule for ands, so S and E is equal to probability of S times the probability of, and then it alternates, so it's S and then E given S. And then the third one you get by just swapping the S and E's in equation 2. So that's E and S is equal to probability of E times the probability of S given E. And then once again, it alternates, so E and then S given E. Part B, find the probability that a randomly selected student does not take economics. So keyword here is not. I'm looking for a probability of not E, not economics. Okay, if I know E is 0.36, not E, right, so that's the complement, we just do 1 minus. So probability of not E is 1 minus the probability of regular E, and that's 1 minus 0.36. 1 minus 0.36 is 0.64. Part C, find the probability that a random selected student takes statistics and takes economics. Keyword here is and. So in symbols, I'm looking for probability of S and E. And the question is, which equation are you going to use? So I have S and E in actually all three equations. So I have it here, I have it here, And then remember, for ands, the order does not matter. So E and S is the same thing as S and E. So it's in equation 3 also. So which one do you use? Remember, in order to use an equation, right, you have to know everything else. So in equation 1, I'm looking for S and E. In order for equation 1 to be useful, I need to know the other 3 things. So do I know S or E? I don't. Okay, so I can't use equation 1. What about equation 2? So I'm looking for S and E, which means I should know the other 2 things. Do I know P of S? Yes. Do I know P of S given E? I mean, probably of E given S? Yes. Okay, so I do know the other 2 things, which means equation 2 is going to be useful. So let me rewrite it. So probably S and E is equal to probably S times the probability of E given S. And then fill in the things that you know. S and E, that's what I'm looking for. So let's call it X. Probability of S, 0.80. Probability of E given S, 0.30. And then fill in the symbols. Right here is an equals. Right here is a multiplication. And then get the X by itself. So right now the X is already by itself. So all you need to do is do the right side. 0.80 times 0.30. 0.24. Right, so what we found was X, and X was the and. So our answer here is S and E is equal to 0.24. Okay, part D, find a probability that a randomly selected student takes statistics or economics. So keyword here is or. I'm looking for probability of S or E. Okay, which equation should I use? There's actually only one equation that has an or in it. And so I have to use equation 1. So let me rewrite it. That is P of S plus P of E minus P of S and E. Okay, fill in the things that you know. Probability of S or E, that's what I'm looking for. So let me call that X. Probability of S, 0.80. Probability of E, 0.36. Probability of S and E. It's not one of these, but we did actually find it in part C, right? S and E is 0.24, so that's 0.24. Go through, fill in the symbols. There's an equals here. Be careful with the symbols. There's a plus here. There's a minus here. And then get the X by itself. The X is already by itself, so all you need to do is do the right side. And it's 0.80 plus 0.36 minus 0.24. And you get 0.92. Okay, so what we found was the or. So probability of S or E is 0.92. Ran out of ink there. Part E, find a probability that a randomly selected student takes statistics given that the student takes economics. I see the keyword given. What I'm looking for here is something given something. Question is it S given E or is it E given S? It's statistics given economics. So it's S given E. All right, let's look at our formulas. Which one has S given E? And remember, conditional probability, the givens, the order does matter, so I do want it as S given E, exactly like that. I see it right here. All right, so I'm going to be using equation 3. Let me recopy it. Equation 3 says probability of E and S equals probability of E times the probability of S given E. Go through, fill in what you know. E and S. For ands, the order does not matter, so E and S is the same thing as S and E, which we did find already in part C, and it was 0.24, so that's 0.24. E, probability of E, 0.36. S given E, that's what I'm looking for. Let's call that X. Go through, fill in the symbols. There's an equals here, there's a times here, and then your job is to get the X by itself. Right now, there's a multiplication there, so to get rid of that 0.36, you're going to do the opposite, which is divide by 0.36. Okay, left side, 0.24 divided by 0.36. And then round it to 3 decimal places, that's 0.667. Right side, 3636 cancels out, and you have just an X, and you're done. So what we're looking for was this probability of S given E, and we found that it was 0.667. Part F, determine if the events taken statistics and taken economics are independent, right? So to check independent, which equation should I be checking? You have two choices. You have this one or this one. We're checking independent, so we're checking probability of A equals probability of A given B. And then let's rewrite this using the letters in this problem. So we're talking about S's and E's. So this is probability of S equals probability of S given E. Okay, find the left side, find the right side, and then see if they're equal. Probability of S, I do know from the beginning, is 0.80. S given E, do I have that somewhere? I do, I have it right here. So that's 0.667. And then our conclusion, they're not equal, so they're not independent. Part G, determine if the events taken statistics and taken economics are mutually exclusive. So here we're checking this equation. So let me rewrite that with S's and E's here. So we're looking for probability of S and E equals 0. Check left side, check right side. Right side's easy, it's 0. Left side, S and E. We probably did that somewhere already. S and E is right here in part C. It's 0.24. Our conclusion, they're definitely not equal, which means they are not mutually exclusive. Have a good day, and I will see you in the next one.